And these are our panelists, as I just mentioned. And without further ado, I'm going to introduce our first panelist, Dr. Andreas Bernhard. Dr. Andy Bernhard is Chief Engineer of the CH-53K program for Lockheed Martin Corporation. In this capacity, he is responsible for and provides for overall strategic leadership for technical activities of the CH-53 program, including design, development, integration, and test, as well as product improvement and design development and all roadmaps. Andy serves as the principal representative to the U.S. Navy and Marine Corps, customer-owned technical matters, and provides management oversight to all program engineering activities and requirements, assuring that all technical program costs, engineering activities, and requirements are met. He also works with the customer in the establishment of technical key performance metrics for measuring 53K performance and progress against contract objectives. Major recent accomplishments for the 53K program include contract award for low-rate initial production, Lot 1, transition of first 2 test aircraft to Pax River for flight testing, 600 flight hours have been flown, and envelope expansion to include max gross weight of up to 88,000 pounds, and speeds in excess of 170 knots. Previously, Dr. Bernhard was a chief engineer in the S-97 Raider program for Lockheed Martin Corporation, S-97 Raider program. In that role, he was responsible for all technical aspects spanning design, development, assembly, and testing through first flight from June 2013 to May of 2015. Before that, he served as Lockheed Martin Corporation's Director and Chief Engineer, Analytics, Technologies, and Engineering for Sikorsky's Aerospace Services. In that role, he was responsible for all aspects of aftermarket engineering, technical publication, flight and maintenance training and analytics from January 2012 to May 2013. Dr. Bernhard graduated from the University of Maryland with a PhD in aerospace engineering. He holds 4 patents and has authored 12 peer-reviewed journal articles and over 20 conference papers. Please join me in welcoming Dr. Andreas Bernhard.
Thank you, Dr. Pines. I should also add that Dr. Pines was one of my thesis advisors, and I still sometimes wonder if I'm going to get one more correction page to make some changes. I'm very excited to be here today to share a little bit of Sikorsky's vision of disruptive technologies, and I'll do that with the 2 videos and 3 vignettes that talk a little bit about the disruption that we are experiencing right now at Sikorsky and the disruption providing to our customer, what we're doing in our commercial fleets, and then a little bit of a forward-looking element of what we're doing beyond that. So let me start off with the CH-53K. Sikorsky Aircraft is a 90-year-old corporation. It was originally founded and incorporated under United Aircraft. They sold us a couple of years ago because we were no longer fit in their business model, and Lockheed Martin decided to pick us up because of a very, very parallel fit and alignment with their business model. But the disruption really is this. Since 1974, Sikorsky has been a Black Hawk company. That venerable aircraft that you have heard about, seen, movies, print, media, performing yeoman service around the world. Over 3,000 aircraft in every armed service in the United States, in many State Department services, fighting fires in California and operating for many air forces, navies, and armies around the world. In the 2020s, Sikorsky will generate more revenue with the CH-53K than it will be with the Black Hawk. Our company is transforming. Not only are we being integrated into Lockheed, but our primary product, our most profitable product, is no longer going to be the Black Hawk, but the CH-53K. And hand in hand with that, we're delivering a capability to our primary customer, the United States Marines, that is truly transformative and disruptive. In the early 2000s, the Marines determined that they needed to triple their payload capability from ship to shore, to triple it. And if that challenge wasn't enough for us, they said, oh, by the way, we're not making you any bigger ships. You have to fit that 3-fold increase in performance into the same footprint. How did we accomplish that? Since contract signing in 2006, we have developed this aircraft that is based on 4 key technologies and an underpinning of digital elements that have made this a reality. Those 4 key technologies are a 79-foot diameter rotor with best-in-class composite rotor blades, the biggest rotor blades in the world. Each of these blades generates enough lift to carry an empty Black Hawk. Each of these blades sees a centrifugal force that is as high as an entire CH-53K hanging off it. Those are connected to a best-in-class split-torque transmission. This transmission has a power density 20% better than anything we've ever built. Dr. Pines worked a lot in transmissions and can appreciate the challenges and complexity of managing both the ability to put 17,900 horsepower through a transmission with a weight that still allows you to have payload in the aircraft. Those are coupled up with 3 GE38 engines. These have 7,500 shaft horsepower apiece, 60% increase in power, 60% reduction in parts. This then together is attached with a cockpit that has a 21st century glass cockpit, fly-by-wire, full authority digital engine controls, Sikorsky's most extensively integrated vehicle health management system, which I'll touch upon in a little bit. And all of this comes together in a composite fuselage that allows the Marines to carry internal and external payloads, threefold performance increase under hot and high conditions. If you can please run the first video. So how do those digital technologies come together to do this for us? First of all, we're using CATIA V5 and LCA in such a fashion that this is Sikorsky's first paperless design. It's all model-based. There are no more drawings. Our engineering bill of materials and our manufacturing bill of materials are fully coupled and therefore provide a seamless integration to the supply chain. The drawing base is such that the technical publications and the training materials flow seamlessly from the parts. We have a collaborative design environment. When we started these trade studies in 2006 with the entire domain space open, this aircraft shares only one common element with its predecessor, and that is the shadow on the ground. Everything else is designed from ground up and brand new. That could only happen with this digital environment we did that in. Beyond that, we used advanced 21st century design tools and analysis to put this all together. So what does that mean? What that means is that we built this aircraft before we flew it. 20,000 parts, over 1,000 work instructions were assembled and tested before we even put the first parts together. The rate of engineering error per drawing was reduced by over 50% compared to historical rates. The rate of rework, for example, in 20 miles of harnesses for those harness assemblies was over 60% lower than we've had in the past. So for us, this was truly a transformative event and disrupted the way we design and build helicopters in order to deliver an aircraft to the customer in a short lead time, manageable cost, and to deliver the threefold increase in performance. As you've seen, this is a machine that will give the customers 88,000 pounds max gross takeoff weight. They can carry 36,000 pounds on that hook. And yes, Dr. Pines, when we were doing high-speed flight, we had to rent a Cessna Citation for chase because no other helicopter in our stable could keep up with it. And what we're doing with that is we're giving it to the customer at an affordable price. What they can do is mean time between flight hours has been reduced by a factor of 3. Maintenance man hours per flight hour has been reduced by a factor of 2, and mean time to repair has been reduced by a factor of 30, or by 30%. I touched earlier on this integrated vehicle health management system. Sikorsky, starting in the 2000s with the S-92, made the decision to change its business model, and every helicopter we have developed since then is equipped with an integrated vehicle health management system. essentially a set of distributed elements, a processing unit, and a spider web of sensors across the whole helicopter. We delivered our first S-92 in 2006, and ever since then, assuming the customers have agreed, we get a nightly download of their data. Over 1.1 million flight hours on 300 aircraft, over 30 terabytes of native data and 140 terabytes of processed data. Long gone are the days when diagnostics engineers, dynamics engineers sat like shamans in a cloud-filled room in the back of the company and stared at squiggly lines of Dr. Pine's kurtosis and inner-race ball energy and things like that. We can no longer afford to do that. What we have done over these past 10 years is to develop the automated tools, the data mining, the decision support technologies, such that we can allow our operators to fly longer hours with less downtime and lower maintenance costs. A couple of examples. In this intervening time, on more than 24 occasions, we have contacted one of our operators and said, you have a part that is going to need to be replaced. We recommend you schedule at your convenience maintenance in the next X hours. Think about that. In the past, the operator would fly the aircraft until either the cockpit warning system went off and said something, or you had a puddle of oil during maintenance, or in the old style of condition-based, the condition indicators, you found something, had to do it. Going from reactive to pre-managed maintenance, a big game changer for our customers. Beyond that, we've all experienced in the aerospace industry fleet grounding. Something happens that you did not acknowledge or anticipate during flight test. The United States Navy had a gearbox problem, the famous cracked carrier plate, wherein they found that when they opened it up, the main element that holds the planetary pinions was cracked and grounded their fleet. At the time, we didn't have the analytic tools. A small company, Impact Technologies, figured out how to detect it if you had the right sensors on it. Well, today, we do have the right sensors on it, and there have been examples in the S-92 fleet where something happened, and we were able to quarantine which aircraft, which components are subject to this condition, and allow all the other aircraft to fly profitably, safely, and effectively. A real game changer for Sikorsky, for our customers who can operate with a higher degree of confidence, higher availability, and for Sikorsky who can provide these services at a higher profitability for operations. For my third element, I'd like to talk a little bit about our intelligence and automation. What you're going to see here is a video that is in 2 segments where a pilot gets into both an S-76 Sikorsky helicopter and then into a Cessna Caravan with nothing but a tablet device to control the aircraft. After the video runs, I'll give you a little bit of context on where we Sikorsky are taking the vision of unmanned flight and the next generation of flight, separate from what you have seen in the public press on electric aircraft and the small single 4-seat type of aircraft, eVelo, and all those very innovative, very exciting technologies. We have a different spin on that. Can you please run the second video? imagine that. What we're looking at are developing and continuing to develop aircraft that have full FAA certification for manned flight, and then have the option of giving the operator, the fleet operator, the battalion commander, the ability to fly the aircraft with one crew member, no crew members, or to simply fly the machine with a mission operator. A scenario, to give you an example, a battlefield in a place where none of us would ever like to be. The commander has 10 Black Hawks at his disposal. For whatever reasons, he doesn't have enough crews, and he needs to run 2 missions. He needs to deploy a autonomous set of vehicles to a place to go and do investigation, whatever they need to do with that, and he needs to go and drop supplies to some people who need it. And he doesn't have enough pilots. He may have one pilot who can go and fly the toughest decision-making mission, and for the others, he can have a guy with a tablet sitting in his tent or sitting stateside, start the mission, fly it from point A to point B, pick up the loads, drop the supplies, and as we've demonstrated, for example, here in West Palm Beach, pick up a linked autonomous vehicle, let the autonomous vehicle and the aircraft talk as to where they need to go land it, drop that vehicle, in this case it was in the swamps behind our flight test facility, let that vehicle go and do its mission, fully autonomous, and then when the mission is complete, in this case a couple of days later, get the call, come and pick that vehicle up and bring it back to its home base. So Sikorsky's vision here is to really change how we look at deploying aircraft and provide decision-making assistance to the pilots, the operators, and give the fleet commander the opportunity to either have pilots in the loop, mission operators in the loop, or in the grand sense, strategic operations where all these aircraft can be deployed semi-autonomously. The last thing I'll share with you is a little bit in the area of artificial intelligence. We have 2 interesting initiatives going on, amongst others, but the first one of them is decision-making. Today's warfighter is inundated with a variable barrage of information. He has to aviate, communicate, navigate. He has sensors from LiDAR to radar to weapons technologies, and he, at any given point in time, has 1,000 rocks to look under. The human brain is a serial processor. We can only do one thing at a time. There's some great Mythbusters episodes out there where people have claimed they can multitask, or proven time and time again that they can't. And so we have this human bias in decision-making. If we let artificial intelligence do the right unsupervised, unstructured learning to help you with that decision-making and identify the 10 rocks that you really need to look under to effectively execute the mission with lethality, survivability, and effectiveness, that's a game changer. And then the last one I'll share with you in this context, which I think is an unusual one, but for our company very, very interesting. You look at large corporations like UTC or Lockheed Martin, thousands of employees, thousands of patents, thousands of technologies, very, very broad interests. And time again, we discover that in our little stovepipe fiefdoms, we try and reinvent the same trade secrets, the same patent applications, because try as we might, we really are not very good at integrating across large domains. And we have a couple of research projects where we're looking at how do we enhance the connectivity across Lockheed Martin Corporation? How do we ensure that people with certain skill sets, certain technical areas of expertise, certain interests, certain projects are connected with, aware of, and provide a productive, collaborative workspace environment that transcends traditional stovepipe boundaries. In that sense, I'm actually very happy to meet a Lockheed colleague here. We'll have to exchange some notes on breaking down some of those boundaries. So from my perspective, a couple of thoughts on digital technologies that are at work at Sikorsky and our large integration with Lockheed Martin. Thank you very much for your time.